I am using say is interpret AS characters mutual information regression say is to pick the best features. For my regression model, it's a way to find out how much information one thing tells you about another. Break time 300 milliseconds in this case, I am figuring out which features in my dataset are most useful for predicting my target variable. Break time 300 milliseconds. I have a dataset with 100 samples. Each sample has 5 features X and 1 target value Y. Think of it like this: I am trying to predict house prices Y. My features X could be things like size, location, number of bedrooms, and so on. Break time 300 milliseconds. I am using a function from the Sklearn library called mutualinforegression. Break time 300 milliseconds. It measures how much each feature helps me predict the target variable. Sklearn is a super helpful Python library for machine learning. Break time 300 milliseconds and mutualinforegression is a great tool for feature selection. After running the mutualinforegression function, I get an array called scores. This array has 5 numbers, one for each of my 5 features. Each number represents the mutual information between that feature and the target variable. Break time 300 milliseconds. A higher number means a stronger relationship. Break time 300 milliseconds. The say as interpret AS characters I say as th element in the scores array tells me the mutual information between the say as interpret AS characters I say as th feature and my target variable. So scores 0 is the mutual information between the first feature and the target. Scores 1 is for the second. And so on. A higher score in the scores array means a stronger relationship between that feature and the target variable. It indicates the feature is more useful in predicting the target value. Mutual information itself is always 0 or positive. It can't be negative. However, because of how computers do calculations, you might sometimes see numbers that are extremely close to 0 but not exactly 0. A score of 0 means there's no relationship between that feature and the target variable. They are statistically independent. Knowing the value of this feature doesn't help me predict the target. This is the overall method we're using, a fancy way of figuring out which features in our data are most important for predicting our target variable. We use a technique called mutual information regression to accomplish this. Break time 200 milliseconds. I have a dataset. Break time 200 milliseconds by represents my features. Think of them as different pieces of information I have about something. And there are 100 examples each with 5 features. Y is my target variable, what I want to predict. I also have 100 examples of this. Break time 200 milliseconds. This statement is correct. Each number in the scores array tells me how much information feature I gives me about the target variable. Break time 200 milliseconds. A higher number means it's more helpful. This is also true. Break time 200 milliseconds. The higher the score, the stronger the relationship between a given feature and what I am trying to predict. This statement is Google style. Name assertive false. Google style. Break time 300 milliseconds. While mutual information is usually positive or 0, computers have limits in precision. We might see values super close to 0, but not exactly 0. So this isn't always true. A score of 0 is accurate. It means there's no relationship at all between that feature and what I want to predict. Break time 200 milliseconds. This is the method. Break time 200 milliseconds. This describes my data. Break time 200 milliseconds. This explains the meaning of each score. Break time 200 milliseconds. This explains the interpretation of the scores. Break time 200 milliseconds. This statement needs to be checked for accuracy. Break time 200 milliseconds. This describes what a zero score means. Break time 200 milliseconds. I am using Google Style Namebold Mutual Information Regression Google Style to pick the best features for my prediction model. It's like a detective searching for clues that are most relevant to the crime. This method helps me find features that are strongly related to the thing I am trying to predict. I have 100 samples. Each sample has 5 features. X is a 100 by 5 matrix. I am trying to predict a single value Y for each sample. Think of this as having 100 patients with 5 measurements each. And I want to predict their blood pressure Y. I am using a handy tool from Sklearn, a popular Python library for machine learning, called mutualinforegression. It measures how strongly each feature is related to the thing I want to predict. The result is a list of 5 numbers. Each number represents how much information each of my 5 features gives me about the prediction Y. A higher number means a stronger relationship. Each number in the list's quasi tells how strongly the ith feature is connected to the thing I am trying to predict. The larger the number, the better that feature is at helping me make a prediction. It's like having a clue that strongly points to the criminal. If a number is 0, that feature is totally useless for prediction. It's like having a clue that has absolutely nothing to do with the case. There is no relationship. This isn't always true. While the mutual information itself is always positive or 0. Google Style name italic numerical issues. Google Style in the calculation might produce very small, almost 0 numbers that are effectively 0. I am using mutual information regression to select the best features for my prediction model. This method helps me find features strongly related to the target variable. My dataset has 100 samples, each with 5 features X, and a single target variable Y for each sample. I am using Sklearn's mutualinforegression function, a tool for measuring feature-target relationships. The function returns a list of 5 scores indicating the strength of each feature's relationship with the target variable. The ith score represents the mutual information between the ith feature and the target. A higher score means a stronger relationship between a feature and the target variable. A score of 0 means the feature is independent of the target variable. This statement is false because although mutual information is non-negative, numerical limitations might produce values close to 0. I am using a technique called mutual information regression to pick the best features for my model. This method helps me understand how strongly each feature is related to the thing I am trying to predict. Mutual information measures how much knowing the value of one thing tells me about the value of another thing. Regression means I am predicting a continuous value, not a category. I have a dataset. X represents my features. It's a table with 100 rows data points and 5 columns features. Y is my target variable. It has 100 values, one for each data point. I am trying to predict Y using the features in X. To perform the mutual information regression, I am using the function mutualinforegression from the Sklearn library. This is a super handy tool in Python that helps calculate how much information each feature gives me about the target variable. After running the function, I get a list of scores. This score list has 5 numbers, one for each feature in my dataset. Each number represents how strongly that feature is related to my target variable. A higher score indicates a stronger relationship. The shape 5 means it's a one-dimensional array with 5 elements. Now, let's test your understanding. I'll present some statements about those scores, and you have to tell me which ones are correct. This statement says that each score in my list represents the mutual information between a single feature and my target variable. That's exactly right. Google style name excited, it's true. Google style. This is also correct. A higher score means a stronger relationship between the feature and the target. More information about one tells me more about the other. This is Google style namesad incorrect. Google style while mutual information is always 0 or positive. Due to how computers handle numbers, I might get values very close to 0. But not exactly 0. Yep, this is true. A score of 0 means the feature and the target variable are completely unrelated, knowing one gives you no information about the other. I am using a technique called say is interpret as characters mutual information regression say as to pick the best features for prediction. It's like choosing the most important ingredients for a recipe. I have 100 examples. Each example has 5 features represented by X, a 100 by 5 matrix and a single target value Y. A vector of length 100 that I want to predict. I am using a function from a Python library called scikit-learn to calculate how strongly each feature is related to the target value. This function is called say is interpret as characters mutual info regression say as. The function gives me a set of 5 numbers. Each number tells me how important each of my 5 features is for predicting the target variable. I have a multiple choice question about the meaning of those 5 numbers that I got. The it number in my scores represents how much information feature I gives me about the target variable. A bigger number means a stronger relationship between that feature and the thing I am trying to predict. These numbers will always be 0 or positive. Although due to computer limitations, some may be extremely close to 0. A score of 0 means that particular feature is not useful at all for predicting my target variable. I am using say is interpret as characters mutual info regression say as a function from scikit-learn for feature selection in regression. It helps me find which features are most important in predicting the outcome. Break time 300 milliseconds. I have a dataset. Break time 200 milliseconds by represents my features. It has 100 samples and 5 features each. Break time 200 milliseconds y is my target variable what I want to predict. It has 100 corresponding values. Break time 300 milliseconds. This is the specific function I use for this kind of feature selection problem. It calculates a special score for each feature. Break time 300 milliseconds. After running say is interpret as characters mutual info regression say as. I get 5 scores, 1 for each of my 5 features. Break time 300 ms. Each score reflects how strongly related that feature is to the target variable. Each score in my result array directly tells me how much information each feature gives me about the target. For example, say as interpret as characters scores 0 say as tells me the relationship between the first feature and the target. The higher the score, the stronger the relationship between a feature and the target variable. A high score suggests that the feature is a valuable predictor of the outcome. I actually need to be careful here. While the underlying concept of mutual information is always positive or 0, my scores might sometimes be really close to 0 due to how the calculations are done on a computer. It is practically 0 but not exactly 0. It won't be negative though. A score of 0 means that the feature and the target variable are not related at all. Break time 300 ms. They are statistically independent. Break time 300 milliseconds. It is like they're living in 2 separate worlds. I am using say is interpret as characters scikit-learn say as. Interpret a spell out mutual info regression says function. A tool that helps me figure out which features are most important for predicting a target variable. In a regression problem, think of it as a detective that ranks clues, with the most informative ones scoring higher. Break time 300 milliseconds. I have a dataset. X represents my features, 5 of them for 100 different samples. And Y represents my target variable measured for each of those 100 samples. Break time 300 milliseconds. The higher the score that says interpret AS characters mutual info regression says gives to a feature, the stronger its relationship with the target variable. It's like saying, this feature is a really good predictor. Break time 300 milliseconds. The say as interpret AS characters mutual info regression says function outputs a score for each of the 5 features. These scores show how strongly each feature relates to the target variable. The output is an array of 5 numbers. Break time 300 milliseconds. Each score's quasi tells me the strength of the relationship between a specific feature I and my target variable y. Higher number means a stronger relationship. Break time 300 milliseconds. A score of 0 means the feature and the target are completely unrelated. There is no predictive value from that feature. Break time 300 milliseconds. While mutual information is always 0 or positive, tiny rounding errors in the calculation might lead to extremely small negative numbers in practice. So, I cannot guarantee only positive numbers. Break time 300 milliseconds.